Hey, do not forget to send us a feedback. We would love to read from you, your name, your school, province, your feedback on how the episodes have been to you. info@crazyphysics.org.za would be a good platform to send us an email, or via WhatsApp 0817442103. Don't forget, we love to read from you. For more of these videos or for more lessons, you can also subscribe to our YouTube channel where you get more lessons, Crazy Edu TV. However, let's get on with the paper. It's been a long, enjoyable morning so far. Without using a calculator, write the following expressions in terms of sine 11. Alright, 5.1.1, this is reduction. 5.1.1. Sine 191. Alright, what do I know quickly? If I draw my quadrants, that's 180 minus theta there, 180 plus theta there, and 360 minus theta. Alright, all science teachers cheat, you know that. Alright, now, in which quadrant do I fall in with 191? I actually fall into the third quadrant because I'm going to need 180 plus 11, which means sine 191 can be written as sine 180 plus 11, but sine is negative. So what's my answer? Negative sine 11. Alright, a quick cheat would be to do this. Because no one is seeing you, sine 191 equals to that. Then shift sign of your answer. And that's your negative there, and your 11. You're done. It's 1 mark. You can quickly use it and put the calculator away. Cos 22. Cos 22, but we're looking at sine 11. Alright, so cos 22 looks to me like cos 2 if I want to bring in 11. And if you go back to your identities, this is basically cos 2 theta. But I want to write it in terms of sine 11. I know that my cos 2 theta is 1 minus 2 sine squared theta because I want sine 11 to be part of my answer. So what would this then be? 1 minus 2 sine squared 11. And we are done. So you need to be abreast of your compound angles, your double angles, the identities. Those things must be close to your heart. Alright, so all you need to do is keep the page opened for your identities. Let's go solve 5.2 quickly. Let's go solve 5.2. Alright, let's see what we need to do here. Alright, it's cos x minus 180, alright, plus root 2 sine x plus 45. Now, if I look at cos x minus 180 and you're good with your reduction, this can be written as cos negative 180 minus x. Alright, cos negative 180 minus x. And automatically, cos has no negative angle, so this is something as saying cos 180 minus x. That's the same thing. But now 180 minus x is in my second quadrant. We just wrote all of that. 180 minus x, and only sine is positive there. Alright, it means cos is negative. So what am I going to have? Negative cos what? X. The negative because it's in the second quadrant. Alright, so now let's break all of this down. What we have, sorry, I'm just going to quickly change that background. No, not a calculator. Alright, so this is what we have. We have cos x minus 180, you remember that, right? Plus square root of 2, let's just check quickly. Remember that, sine x plus 45, beautiful. Sine x plus 45. Already we dealt with this and said this is equal to negative cos x. I'll show you another way. It'll take a few more seconds, but you'll be so sure. All right. Okay, we can expand this as sine x cos 45, I'm sure you know this, plus cos x sine 45. I've got some special angles here. Now, negative cos x plus root 2 sine x. All right, this can be written as root 2 over 2 plus cos x, again, root 2 over 2. What then do we have? Let's see. Negative cos x, root 2 times root 2 would give me what? 2 divided by 2. Oh, this gives me sine x. The same dynamics here. All right. Oh, by the way, why did I remove that root 2 is a bracket there? All right. That root 2 multiplies the whole thing. Root 2 multiplies this whole thing. All right, so I need a root 2 here as well. So root 2 times root 2, 2 divided by 2 would give me 1, and that would give me cos x. So cos x minus cos x, I am left with sine x, and I think we are good to go. The question says simplify to a single trig what? Ratio, and that's done. All right, let's look at 5.3. You've got to be creative with maths. That's the whole idea. Your creative juices must just be in play. Okay, let's see. We still have a long way to go, but I'm sure it has been absolutely phenomenal. All right. Now, look at this. I have sine. Okay, just a second. Just need to take this out. All right, just need to take that out quickly. Given that sine p plus sine q equals to 7 over 5, and p plus q, oh, this is actually talking about complementary what? Angles. There must be something there. Without the use of calculator, find the value of sine 2p. All right, let's see something here. You know, the first thing I would do is to look at sine 2p and try to expand it to see where I'm going to get. Sine 2p is 2 sine p cos p. Watch this. This here looks like the sum of a trinomial. Also, if it is a trinomial, let's try to play around. All right, let's try to play around. If sine p plus sine q, let me get a fresh page. All right, so if sine p plus sine q is equal to, let's get that value right, 7 over 5. I can square this. Let's square both sides. What am I going to have? Sine squared p plus, remember sine p multiplied by sine q would give me 2 sine p sine what? Q plus sine squared q, and that is 7 over 5. All what? Squared. We're getting somewhere. We're getting somewhere. There's just a little problem. There's a little problem. Okay, I know that sine. Okay, hold on. This is q. There's a little dynamics that we need to then use here. All right, what is my dynamics? Look at my complementary angles. P plus q is equal to what? 90. What does that mean? It means that since P plus Q equals to 90, it means that sine P equals to what? Cos Q. And it means that sine Q equals to what? Cos P. Complementary angles. So sine squared P plus 2 sine P, hold on, let me write my P as capital. Because I've been writing as small letter. Okay, let's just keep it there. Sine P. Now, what is sine Q? Sine Q is cos P. Plus, what is sine squared Q? By the way, sine Q is cos P. the second one. So I would have cos squared p equals to 49 over 25. Makes sense. Sine p and cos p would give me 1. So 2 sine p cos p is equal to what? 49, remember? 49 over 25 minus 1. Oh, what is this? This is sine 2p. That's where I'm going. Now, what is 49 minus 1 over 25? That will be 49 minus 25, which will be 24 over 25. Very lovely dynamics here that we need to then play around with. That is so beautiful. Such a beautiful, beautiful question. Now we're going into the deep waters. Determine the general solution of cos x minus 30. Let's write it nicely. Cos x minus 30, equals to 2 sine x. Let me just get a fresh page. Cos x minus 30 equals to 2 sine x. I think I'm just going to open my, deal with the left hand side and write it as cos x cos 30 plus sine x sine 30 equals to what? 2 sine x. That's beautiful. We need to walk around and see how we are going to get a solution here. Alright, I do know that my cos 30 is a special angle root 3 over 2. Okay, so let's have this. Root 3 over 2 cos x. Sine 30 is half plus half sine x. Alright, let's see something here. If I bring this here, 2 sine x equals to 0. Let's see. Oh, they are like terms. Let's do something here. Cos x. Now, half minus 2 would be what? Negative root 3. Alright? So, understand what I did there. It's like saying half x minus 2x. We're going to get negative, is it root 3? Negative 3 over 2. Not root 3. Negative 3 over 2. Let's clean that quickly. It's negative 3 over 2. Awesome. Now, I have a sine, a single identity of sine and a single identity of cos there. I'm beginning to look towards tan. Let's move all of this over to the other side. So, root 3 over 2 cos x equals to what? 3 over 2 sine x. Can we get a tan? Let's divide both sides by, because I want that, so I'm going to divide both sides by, okay, let's make it easy for everyone. Let's divide both sides by sine x, because I wanted to combine. But some people do get lost there. Alright. Oh, no, I should do it the other way around. Doesn't really matter though. I could still change it. But let's do it the other way around. Let's divide both sides by cos x, so that I would then get my straight tan. Alright, so what do we know? I'm going to just break this page. Root 3 over 2 equals to 3 over 2 tan x. Alright, let's divide both sides by 3 over 2. What am I going to have? Times 2 over 3 equals to what? Tan x. So what do we have? Tan x equals to what? Root 3 over 3. Now, this is positive, and tan is positive in the first quadrant. So x equals to what? Shift tan root 3 over 3 plus k 180, where k is an element of integers. We can then plug all of this in our calculator. Shift 10, we have that, which is square root of 3 over 3, and we close the bracket. What do we have? Oh, 30. That's beautiful. 30 plus k 180 degrees. All right, don't forget that tan will always repeat its cycle at what? 180 degrees. Beautiful. Beautiful, beautiful stuff. Beautiful maths. Okay, we're still working. Now we have a graph. We have a graph. Let's just get this graph. Let's get it onto a fresh page. So this is Trig's. Okay, I should have just cloned this and returned this there. Okay. All right, now we have a graph. Let's walk around the graph. In the diagram, the graph of f of x, which is cos x minus 30, and g of x, which is 2 sine x. Oh, these are the same questions we just did. Are drawn from the interval x minus 180 plus 180. Okay. A and B are the x-intercept of x. The two graphs intersect at C and D. The minimum and maximum turning point of, respectively, of f. Okay. Alright, so D is the maximum and C is the minimum. Write down the coordinate of A. Tricky. Now, let's see. What do you know about A? About f? Look at my f of x. It is cos x minus 30. So basically, it is cos x that shifts where? To the right. Now, if it shifts to the right, let's see. At point A, our y value is actually equal to 0. But if I had the normal cosine graph, where will it be 0? It will be 0. Cos 90 is 0. But now I have shifted this graph 3 units to the right. So what am I going to have? Cos 90 plus 30. And that will be cos what? 120. I hope this makes sense. Cos 1 what? 20. Because it has shifted. So what is the coordinate of A? 120 degrees and 0. Alright, beautiful. Coordinate of C, where is C? Oh, right there on the left. Now, that is a point where they intersect. Alright, that is a point where they intersect. Don't forget, your graph has shifted to the right by how many units? By 30 units. Alright, it means that my amplitude is still the same. For a cos graph, you need to know your cos graph. Let me help you here. Your cos graph actually cos 0 there, alright, and cos 90 there, negative 90, alright, such that, okay, I've gone beyond that, such that that is negative 1. So you can see it has shifted to the right. That means by 30 units, that point has to be negative what? 150 degrees. Alright, because that's where my negative 1 is now. But the graph has shifted to the right. So 180 to 30 units to the right will give me what? 150. So what's my coordinate there? Negative 150 and, no, not 0, negative 1. So my graph has been shifted 30 units to the right. Awesome. Let's look at the next question. Determine the values of x in the interval that for which both graphs are increasing. Alright, where are both graphs increasing? I like to use where the gradient is increasing. So I'm just going to draw gradients quickly. Alright, check this. Right from here, there's an increasing function there. Okay, also that is increasing. Okay, so the increase actually stops there. Let's see. That's where that is increasing. And from the turning point to the other turning point, that's where it's increasing. But the question says we want both graphs to be increasing. So where is that interval where both graphs are increasing? I'm going to draw a line there. Alright. And the other line would be here. All right, because after that point, the other one starts decreasing. So, what are the values of these points? A, 6.2.2. All right, guys, don't forget that your graph has shifted to the right. So, O was supposed to be here. That point, let me use it different. It was supposed to be here, but it has shifted to the right by 30 units. So it means point O there is 30. And what about this point? All right, what about that point? Okay, now that point is going to be, let's look at our cost graph again. Oh, look at where we are now. We have moved until we got to 0 there. All right, normally we know that it is cos 90 that is equal to 0, or negative, or cos negative what? 90. Is that okay? But now we are moving. So if we move, what will our answer then be? 6.2.2. A. No, change the marker. Now it's going to be between these two values. Already I'm going to have that, and O is already 30 degrees. So our challenge now is getting this other part. But can we work with the sine graph this time around? Because we need, let me come here. We need this value of a sine graph. Wait, what did we do to the sine graph? We only increased the amplitude. Ah, so where is the minimum value of sine graph? It is going to be 90 degrees. Sine 90 is 1, but sine negative 90 is negative 1. So I'm going to have negative 90 degrees less than x less than 30. All right, that's where both functions are increasing. All right, B, fx plus 10 is greater than g x plus 10. So basically we are shifting this graph 10 units to the left. Now let's check something. Where are these graphs greater than each other? Let me quickly erase this. Oh no, I'm erasing the wrong thing. Let me take this out. Okay, I wanted to follow this very closely. This is very challenging. Now, where is f of x itself greater than g of x? It is between C and D. All right, remember what the value of D is. This is 30. And what is the value of C? Negative 150. All right, now those are the value of f of x greater than g of x. But what are we doing to the two graphs? When you say plus 10, we are then shifting to the left. All right, plus is shifting to the left. By how many units? By 10 units. What would my answer then be? So look at this. My answer should have been negative 150 less than x less than 30. But if I'm shifting to the left, all right, by 10 units, what do? This one now becomes what? Negative what? 160, all right, less than x less than 20. I am shifting to the left. I hope it makes sense. Let's go back to the graph. If I move from here and move 10 units, then I'll move negative what? 160. If I move 10 units to the left here, then I'll be going to what? 20. So it is between negative 160 and 20. That's how it works. All right, 6.3, 6.2.3. You know you've got to learn your function, your trig very well, and it is a very good place to score these marks that we're looking at. Just a bit of critical thinking here and there. All right, like this one, find a range of y equals to 2 sine x plus 3. Okay, range. I'm going to need my maximum value and my minimum value, but I'm going to work with this. So let's work with this. 2 sine x plus 3. What is the minimum value of sine x? Minimum of sine x, if you remember the graph, it is -1. So what are we going to have? 2 multiplied by -1. That's the minimum value. All right. 2 negative to 3. 3 minus 2 would give us what? 1. That's the minimum. What about the maximum? Let's see. The maximum. Maximum is +1. What are we going to have? 2 multiplied by 1 plus 3, and that is 5. So my minimum for that expression is 1 and the maximum is 5. So I will then have y equals to 2 to the power 1 as my minimum and y equals to 2 to the power 5 as my maximum. So my range would be between 2 and 32. I hope you understand where the 32 comes from. 2 to the power 5. Very lovely. And it creates your algebra. It brings back algebra in its full perspective. Okay, beautiful. Let's look at the last question on trigonometry, after which we would go to the Euclidean part of this paper. Now, in the diagram below, CGFB and CGHD are fixed walls that are rectangular. Let's quickly go look for these beautiful rigid walls. CGFB, where is it? CGFB, okay, that's the wall. And CGHD, also we've got the 2 walls there. Beautiful, makes sense now. So we have those 2 walls there, are fixed walls that are rectangular in shape, all right, and vertical to the horizontal plane. FGH, steel poles erected along FB, all right, steel poles, and HD extend to A. Awesome, all right, and E respectively. Good. And triangle ACE, let's find that. Triangle A, all right. Triangle ACE forms the roof of the entertainment center. Okay, BX is 6, that has been written for us. CD is x plus 2, written for us. ACE is 20. Okay, ACE is 20, and ECD is 6. So we have all the angles written. Okay, let's start working. The first one says, write down the length of AC. In terms of, oh, that's very simple, because that's my AC there, and this is 90 degrees. I could use my trig ratio. So this is opposite, and so sine theta, no, I always forget to do this. Sine theta, what is opposite? X over AC. So what is AC? X over sine theta. Done, because they want us to write it in terms of x and sine theta. What about CE in terms of x? Where is CE? Now we know this. Let's go write something there. I like to write this in my paper. What is this? X over sine theta. Now, how then we want CE? We want CE. All right. You need to remember your sine rule, your cosine rule, and all of those, your theorem of Pythagoras. But in this case, what do I have? All right. I've got x over sine theta, and I've got angle ACE as what? 2 theta. Very important stuff. Now, you know what I can then do? I can get this guy and then use either my cosine rule or something there. I can get that guy from the Pythagoras theorem that it falls on. So can I say, let me write in blue, this is opposite, and this is hypotenuse, and this is what? Adjacent. I'm looking for that. Oh, beautiful. So what is that? Cos 60 is x plus 2 over what? CE. What is CE therefore? CE is x plus 2 over cos 60. I hope it makes sense. And cos 60 is equal to half. So CE equals to what? X over 2 divided by 1 over 2, which is times 2. So CE actually Can we say c is equal to x? Let's check again. Cos 60 is sine 30, which is half. Oh no, it is x plus 2. Sorry, it is x plus 2. I was so excited. CE is x, I missed the plus 2. Alright, over 1. Remember, it's divided by half, so times 2. So CE is 2x plus 4. Oh, done. CE is 2x plus 4. This is what I want. CE is 2x plus 4. Now, show that the area of the roof ACE is given. Let me write this here. So when I clone this page, this is 2x plus 4. Show that the area of the roof can be written. Okay, let's go work that out. Let's go work that out. We're almost done with this, and then we would hit our Euclidean geometry. Show that the area of the roof. Now, ACE, what's the area? I could use half AB sine C, which is half the two lengths, AC, CE, and then sine C. Let's see. Half. What is my AC, by the way? X over sine theta. What is my CE? My CE is 2x plus 4. Sine C is 2 theta. All right, let's see. We need to get rid of that sine 2 theta. Okay, let's check something here. There's no more half. It's 2x. We need to play around now. All right, half x over sine theta multiplied by 2 into bracket what? X plus 2. Already I have my x plus 2 there. Okay. Multiplied by 2 sine theta cos theta. Awesome. I see my answers. That 2 can take that 2 out. That sine can take that sine out. What do we have? X times 2 would be 2x into bracket x plus 2, and we have cos theta remaining. This is absolutely beautiful. Absolutely beautiful. So you need to know your area rule. Okay, 7.3. Let's get 7.3 done quickly before we jump into the next section. If theta is 45 and BC is 12, calculate the length of AE. Let's go find AE. Calculate the length of AE. Guys, you must know your sine rule and your cosine rule. Not just knowing them, knowing when to use them. Quickly guide you. When do you use cosine rule? When you have 3 sides, or you have 2 sides plus an included what? Angle. Alright, so in this case, look at what I have. I want the length of that, but I do have all of that. Awesome. So I have 2 sides and an included angle. Okay, so I will then say AE squared equals to the 2 sides squared, AC squared, plus CE squared minus 2ACCE cos of that angle, cos C, the angle facing the side. Okay, let's walk through. AE squared. What is my AC, by the way? X over sine theta, and my X is 12. So 12 over sine 55, theta is 55, all squared, plus, now what is CE? 2x plus 4. I can substitute that quickly. 2 times 12 would give me what? 24. 24 plus 4 would give me 28. That's very straightforward. Minus 2 into bracket 28. Alright, let's deal with this section now. What is my CE? 12 over sine 55 cos 110. I could just change this to 2 theta. And our theta is 55. Alright, I think we can put all of this in a calculator and get a final answer. Let's get a calculator quickly here. What do we have? Bracket. We have 12 over sine 55 let's close the bracket, but there's a major bracket there, big bracket, squared plus 28 squared minus 2 times 28. All right, close the bracket. What do we have? 12 over sine 55. Your calculator is powerful. It will do all of this before you even blink your eyes. Just put it in nicely, cos 110, and close the bracket, and your answer is 1279. But this is the square. I need to find the square root of that answer. Oh, 35,77. 35,77. And this is in meters. Great. So this is your trig. Please let me just quickly do a crash course here. Sine rule and cosine rule. Here you use it when you have two sides plus a non-included angle. That is angle that is not in between the two sides. Here you use it when you have three sides, and here you use it again when you have two sides plus an included what? Angle. What do I mean by included angle? I'm giving that side 5, I'm giving that 7, and I'm giving that 20. The angle is included in both. Alright, so and the formulas are on the formula page. Please make use of your formula page. Beautiful. That's my trig. I hope you learned one or two things. Okay, let's conclude our trig section here with just this beautiful question. Now, if cos 22 equals to p, understand what that means. Number one, you need to draw, you need to sketch. Is that okay? We need to sketch our quadrants. Very, very important that you sketch your quadrants. Okay, now cos 22 falls in the first quadrant, so our triangle looks like this in the first quadrant, and that is 22. But what does that mean? Cos 22 equals to p over 1, and we know our cos is adjacent over hypotenuse. Alright, so this becomes my opposite, the side that faces the angle. This becomes my hypotenuse, and this becomes what? Adjacent. Alright, so my adjacent is 22 and my hypotenuse is 1. So what is, sorry, not 22 rather, p. Alright, now what is the opposite side going to be? It's 1 minus p squared. That you need to do before you even start. And this angle will be 68. Remember, angles in, some of angles in a triangle. Alright, now let's quickly run through the 3. But this is the first step that needs to be done. You cannot go on without having this done. Now, what is cos 158? 158 already tells me I am in the second quadrant. And in the second quadrant, remember, all science teachers cheat. In the second quadrant, cos is negative 180 minus theta. Alright, so what are we going to have? Cos is negative, so it's going to be negative. We need to reduce 180 minus. If you check your calculator, this is what you need to do on your calculator. Oh, sorry, I moved pages. This is what you need to do with your calculator. Just say 180 minus 158, 22. And put the 22 there. Alright, so 180 minus 22 would give me 158, and cos is negative in the second quadrant. So this is negative cos 22, and cos 22 is p, so this is minus p. Done. Let's look at sine 112. Sine 112, I'm again in the second quadrant, but this time around sine is negative. Go back to your calculator and then say 180 minus 112, and that gives me 68. Oh, so this is 180 minus 68, and that gives me sine what? 68. And if you go back to your triangle, do you see your sine 68 already? And sine is opposite over what? Hypotenuse, which is what? P. Because sine 68 is also equal to cos 22 when we talk about co-ratios. Now look at the next one. Alright, sine 38. Let's quickly work around that. Sine 38. Now if you check your what you have, 22 and 68, 38 has got nothing on this too. So you need to play around with numbers. And what I'm going to do is 68 minus 38 would give me 30. 68. Okay. So basically, I can then say this is sine. Remember we said 68 minus 38 would give me 30. So I can say this is sine 68 minus 30. I hope that makes sense. Alright, because now I'm trying to bring in my special angles. And you know what sine 68 minus 30 is? Formula page, sine 68 cos 30 minus cos 68 sine 30. Now, what is sine 68? Sine 68 is P. We're going to try this in different ways. And cos 30 is root 3 over 2 minus, what is cos 68? Alright, now if I'm using 68, adjacent would be 1 minus p squared, the square root of that. Alright, I'm using 68. So I have that. 1 minus square root of p. 1 minus that. And my sine 30 is a half. Alright, basically there is nothing I can do here. I'm going to leave my answer like that. Let's try something else and confirm. Sine 38, I'm also thinking, can be written as sine 60 minus 22. Yes. And this will give me sine 60 cos 22 minus cos 60 sine 22. Be familiar with the formula page. Sine 60, which is root 3 over 2. Now, what is cos 22? That's where we started from. P. Minus. Now, what is cos 60? Cos 60 is half. Now, what is sine 22? Let's go. Opposite. Alright. 1 minus p squared. Alright. The square root of that. Oh, what do you notice? We actually get back to the same answers. Alright. So this is how you work around your trigonometry. Alright. Now, the next question is to then deal with, there we go, some theorems. In the next few breaks, we will then run through our theorems, what I should be knowing, the theorems I should be able to prove going into my exam on Monday. Alright, so let's deal with some Euclidean geometry now.